Here we have a grade 11 November exam written in Gauteng 2023. If you want to download the paper, check the description below. Given that k is equal to this expression, show that k is rational if p is 3. Okay, so all we'll go and do is we'll just go and fill in 3 in the place of p. Okay, I don't need that to be that big, and then this is on the outside. Okay, and if we had to go solve all of this, you're going to get 5 over 5 plus 1. Now 5 over 5 is 1. Now the square root of 1 is 1 plus 1, so the answer is 2. We know that 2 is a rational number. For which values of p will the expression be real? Well, let's first talk about non-real. Non-real is when you have a negative value or answer inside a square root. So for which values would it be real? Well, for it to be real, it would be 0. It would have to be 0 or anything positive. Okay, so we want whatever's inside the square root to be bigger than or equal to 0. Now, when solving this, it's not the same as an equation where you have that, because in this scenario we would probably just take this over to the other side, and you would end up getting 5 equals to 0, and there'd be no solution. But when you have an inequality, you never want to take the variable, you never want to multiply the variable over like that. So what we need to do is just think about this very carefully. We want this expression to be 0 or positive. It cannot be 0. There is nothing you could put over here that'll make this expression, that'll make this whole expression 0. The only way to have a 0 in a fraction is if the number at the top is a 0. Okay, so we're not going to worry about equal to 0, but let's worry about how could we make this expression positive. Well, we know that this number at the top is already positive, so what would this expression at the bottom have to be so that this whole thing is positive? Well, you would want this to also be a positive. So that becomes our little thing that we want to go solve. We want to know where is p plus 2 positive. Positive means bigger than 0. And so if you had to go solve this, you would end up getting that p must be greater than -2. Solve for x, and they said correct to 2 decimal places. When they say that, it means that you're going to use the quadratic formula, because it cannot factorize. Because if it could factorize, you wouldn't be getting decimal answers. Okay, so the quadratic formula goes like this. So just to be safe, write it down in an exam, and then also fill in the formula. So we know that, we first have to move everything to the one side. I didn't even realize that. Okay. Now we know that a is always the term in front of the x squared, b is always the term in front of x, and then c is the other part. And so go fill that all in. So whenever b is a negative, I always use a bracket. -4. Now a is 3, and c is -2. And then a is 3. Okay, now the rest you can just go type on the calculator. So for the first part on the calculator, I'm going to put this as a plus, and then for the next answer, I'll put it as a minus. So to 2 decimals, you're going to get 1.72, and the other answer is going to be -0.39. Here we have an inequality. So what I always do is we take everything to the one side. So it'll become +21. Now what you do is you do a little side calculation where you need to go calculate your critical values. And to do that, you can make it an equal sign. Then you just go solve this normally. So this can factorize quite easily as x plus 7, x plus 3. And so x would be -7 or x would be -3. Now, when you get these numbers, go put them on a number line. Okay, now, this is a parabola, and because this number in the front is a positive number, it's a smiley face parabola. It's a happy parabola. You can see the smiley face over there. If it was a negative in front of the x squared, it would go like that. Now they want to know, where is this parabola bigger than 0? Bigger than 0 means above the x axis. Okay, so where is this graph above the x-axis? Well, if this is the x-axis, then the graph is above here and here. So now we need to go give that as an answer. So for this part here, those are all the x values that are smaller than -7. Then you say or, and then these are all the x values that are bigger than -3. Whenever it's to the left of something, it's smaller than, and whenever it's to the right of something, whenever x is to the right of something, then it's always going to be bigger than. Now, if you want to use interval notation, you would go from -infinity up to -7, and then you could say, or from -3 up to infinity. Okay, whenever we have an equation where we've got square roots like this, we need to get rid of the square roots. So in this question, what we can do is we can square both sides. And so what happens is that this 2 completely removes the square root. So you're just going to be left with x squared minus 5. And then on this side over here, because it's one term, this 2 can go there. So that will become a 4 because 2 to the power of 2 is 4. And then this 2 would also go to this. And we know that this 2 would completely remove that square, and so you'd just be left with whatever's inside, which is just x. Now it's just a super easy, straightforward question where we can just go and factorize. So this would be -5 and +1. And so therefore x is 5 or x is -1. But if you want to get full marks for these questions, you need to now do a check. So how do we do a check? Well, I'm going to start by I'm going to look at x equals to 5. So I'm going to go plug x equals to 5 onto the left side and the right side of my equation. And so if I plug it in on the left side, I get 5 squared take away 5. And if I plug it on the right side, I get 2 square root 5. So let's see if these two expressions are equal. This gives us 20. And if you type in square root 20, it gives you 2 square root 5. And this is also 2 square root 5. So the left side is the right side. And so that's all good. That makes sense. Let's go check now if x is -1. Then we're going to fill in the left side and then the right side. So if you fill in the left side, you're going to get -1 squared take away 5. And if you fill in this side, you get 2 square root -1. Both of these are actually going to give you an error. And so this part doesn't make sense, and so all that you do is you just put a line through that one. With these kind of questions, what I would always do is I would break this up into 3 to the x, 3 to the 1, and then the same for the next part. Okay. I would then take out a common factor of 3 to the x, and so you'd be left with 3 plus 3 to the -1. I would type this on my calculator, and that gives 10 over 3. I would then get this by itself. The way that I would do that is I would divide both sides by 10 over 3, and so these would cancel, and so you're left with 3 to the x equals. Now this you can just type on the calculator, and it's just going to give you 1 over 3. Now when we are solving exponential equations, we want these two to be the same. So what I'm going to do is I'm going to rewrite the 1 over 3 as 3 to the -1. That is exactly the same as 1 over 3. Okay? And so when these are the same, you can ignore the 3's now. And so x would simply have to be -1. Given that x plus y is 2 and y plus 1 is that, solve for x and y. So we've got two equations. I'm going to call that equation 1. I'm going to call this one equation 2. I want you to take the most simple looking equation. That's this one over here. Get x or y by itself. You can decide. I'm going to get y by itself. So I'm going to say y equals, and then I'm going to take that x to the other side. That is going to now be equation 3. I'm then going to substitute that equation 3 into the equation that I haven't yet used, which is equation number 2. So what does that mean? Well, if you look carefully, we're saying that y is the same as 2 minus x. So when I go to equation 2 now, wherever I see a y, I'm going to replace it with 2 minus x. So that's going to become 2 minus x plus 1 equals to -3 over x minus 1. just going to simplify the 2 and the 1 so long. That's going to give us 3. Okay. Now we're going to, there's multiple ways that you could think about this next part. You could either think about it as 3 minus x over 1, and then you're just going to cross multiply. Okay. Or you can think of it as 3 over 1 and x over 1, and then you're going to go get a common denominator, which is x minus 1. I prefer to keep it like that, where I just go do cross multiplication now, so I end up getting that over there and that over there. Okay, I'm then just going to multiply this bracket out, so it becomes 3x, take away 3, take away x squared plus x equals to minus 3. Now we can just simplify a little bit. So you're going to eventually end up with minus x squared plus 4x equals to 0, because these minus 3's are going to cancel out eventually. So just want to double check, minus x squared, yeah. Okay, now you're just going to go and solve. So how would you solve this? Don't take the one, don't do something like this. You never want to end up with a situation like that. You rather take everything to the one side now, and now we're going to factorize. So I'm going to take out an x, and then you'll be left with minus x plus 4. And so if you now solve, you get x equals to 0 or x equals to 4. Now we have both of our x answers, but we still need to go get y. So you come back to equation number 3 over here, which says that y is equal to 2 minus x. So for the first one, I'll plug in a 0, so y would be 2. And then for the next one, I would plug in a 4, and so y is minus 2. Okay, so we now have our answers for x and our answers for y. So now this question says, determine the value of 1 over x plus 1 over y. Okay, so we're going to do two different scenarios. We know that when x was 0, y was 2, so they go together. And then when x was 4, y was minus 2, so they go together. Okay, so let's go do the first one, where we're going to go fill into this now. So 1 over x plus 1 over y. So for the first one, x was 0 and y was 2. Well, that's going to give you an error on your calculator because that is undefined, and so there's no solution there. And then for the next one, we're going to have x as 4 and y as minus 2. And you could actually just go type that on the calculator, and you should get an answer of negative a quarter. So they give us an expression where m is not equal to 0. Determine the values of m for which the equation has real roots. Okay, so this is all just nature of roots. Let's do a quick summary. We know that nature of roots is the b squared minus 4ac. If it is ever equal to something that is negative, we call that non-real. And then if it is 0 or anything positive, then it's real. Now within the real category, there are 3 different options. If it is equal to 0, then we call that equal. If it is a perfect square, like 25, 36, you know, those perfect square numbers, then we say that it's rational. And then if it's anything else, like any other number, 17, 41, whatever, as long as it's not a square number, like a perfect square, like 25, 36, 81, then we just call it irrational. Try to write that a bit better. So this one here is irrational. Okay, so they want to know, what must the value of m be so that the roots are real? Well, where do we see real over here? Well, real is here. So we know that the b squared minus 4ac must be bigger than or equal to 0. That's exactly what this is saying. It's saying that it can be 0, but it can also be something that is positive. So that is what that says over there. Okay, so now we know that a is always the thing in front of the x squared. We know that b, sneaky, sneaky, sneaky. That's going to catch out a lot of students. The standard equation goes ax squared plus bx plus c, but now they've put a negative there, but the standard has a positive. So we have to fix that. So we have to rewrite it as 2mx squared. Now we're going to change it to a positive, but because we've now changed that to a positive, the signs inside here have to change. So the 2 will become positive and the m will become negative. So they switch, and then the rest is all okay. So your value of B is this one over here, and then your value of C is that over there, and then your A is that over there. Okay, so let's go fill everything in. We filled in B, now we fill in A, and now we fill in C, which is m plus 1. And we want that to be bigger than or equal to 0. Okay, some learners are going to make a mistake here. They're just going to say 2 squared and m squared. Rather, you have to make double brackets, or you can multiply it out the long way, but just doing it in your head. Some learners are quite good with that. These two I'm going to multiply together to give 8m. There we go. Okay, now we're just going to get 4, take away 2m, take away 2m plus m squared, minus 8m squared minus 8m after you've multiplied those in, and then that. Okay, now it's going to put things together. So this is going to give us minus 7, because that's a 1 over there, so minus 7m squared. For the m's, we're going to get minus 2, minus 8, which is minus 12. And then this is just the random little plus 4. Now, if I was sitting in an exam, I wouldn't waste time trying to factorize this. I would just go straight to the quadratic formula. But we must remember that it is an inequality. So we actually need to go get the critical values and do all of that. So you can do like a little side calculation on your exam paper, and you can just tell the teacher that this is where you are getting your critical values. If you can't see that word, it's critical. And the way you can do that is you make it equal to 0. Then you can go use the quadratic formula over here, okay? And you should end up with 2 answers for m. The first one would be 2 over 7. And the other one is minus 2. Okay, so we're going to go draw a number line now. And then go put those two critical values. So minus 2 comes first, and then 2 over 7. Now, if you look at this expression, it is a parabola, because it's got that square term, so it's a parabola. And it's got a negative in front of the square term, so it's an unhappy, or it's an upside down. It's an upside down parabola, so it's going to go like that. Now, they want to know, where is that parabola bigger than or equal to 0? That means above the x-axis. Above the x. So if your x-axis is here, then where is the graph above? Well, it's all of that. So it is when m is between minus 2 and 2 over 7. If you rather want to use interval notation, you could say that m is an element going from minus 2 to 2 over 7, like that. And then this question says, determine the value of m so that the equation has 2 roots that are opposite in sign. Okay, so this isn't going to be anything to do with this. If I show you a couple options here, let's say, for example, you were busy solving an equation one day and you ended up with x equals to 2 or x equals to 3. Then if you had to put that into brackets, that would be x minus 2 and x minus 3, right? So can you see that because these two are the same, their sign over here is going to be the same. So when you multiply, if you had to multiply them out, let me actually just multiply it out and show you, you'd eventually get x squared minus 5x plus 6. So notice that that's positive. Now, if you had 2 roots that were, let's say, x equals to minus 3 and x equals to minus 4, if you had to put that into brackets and you had to multiply that out, you would eventually get that. So you see how we're getting a plus and a plus. So whenever c is a positive number, then your 2 answers that you get have the same sign, positive, positive, or negative, negative. But as soon as you want one of them to be positive and the other to be negative, then if you had to put that into brackets and then multiply that out, you would eventually get minus over here. So here's a rule. When c is negative, the answers or the roots are opposite sign. On this memo for this paper, they said it the other way around, which they've made a mistake. When c is a negative number, you can even go check on Google, wherever you like, trust me. When c is a negative, like we had over here, remember that's your C value, then the answers are always going to have opposite sign. When your C value is positive, like we had over here and over here, then your signs are going to be the same. So if you want to have roots or answers that are opposite in sign, then you want the C value to be smaller than 0, which means negative. So if you look at your C value, it's there. And we said that for the signs to be opposite, we want that to be smaller than 0. So then if you go solve, you're going to end up with m must be smaller than -1. As I said on the memo, they got that wrong. They got this part completely the opposite. Trust me, that is a mistake on their side. Here they want us to simplify without using a calculator. All right, so all that you're going to do is you're going to take the number 512, type it on your calculator, press equals, then press the shift button, and then press the button that has fact. And it'll break 512 down into its prime factors. So if you've done that correctly, you should get 2 to the power of 9. So we're going to have it as 2 to the power of 9, and then there's a x3, and then at the bottom, we're going to do the same with the 64, and that'll be 2 to the power of 6, and then we still have x to the power of -3, and then on the outside, we've got -1/3. Okay, so there's multiple ways that you could go from this step. What I'm going to do is I'm going to use exponent rules. So I'm going to use it with these two because they have the same base. And then after that, I'm going to do, let's do a different color. Let's do a light green. I'm going to do those two. Okay, so a lot of learners, they're going to make the mistake of canceling the 2's out. But remember, if you have something like A7 over A2, then the answer stays A. You see how we don't cancel the A out, and then we subtract these two, so that'll be 5. So we're going to leave the 2's exactly where they are. Okay, then you're going to subtract the exponent, so it'll be 9 minus 6, which is 3. Okay, then for the x's, you're going to subtract the exponents, so you're going to say 3 minus 3, so it actually becomes 3 plus 3, which is going to be 6. What some learners maybe would have liked to have done over here is, you see, because this has a negative exponent, they would have maybe taken it up to the top to make it a positive exponent. Then if you have these two next to each other, what do you do when you have like a3 times by a2? Well, then what you do is you add. So you would have added these exponents to become 6. And so we now have -1/3 on the outside. So what the exponent rules tell us, if you remember, if you have like a to the 3 to the power of 4, you multiply. So we're going to multiply those two together, so that'll be 2 to the -1. And then we're going to do the exact same with the 6 and the -2, and that'll be -2. Alright, and then they typically don't want you to leave your answer with negative exponents like that. So we know that 2 to the -1 is the same as 1 over 2. And we know that x to the -2 is the same as 1 over x squared. Then you can just multiply top and top and bottom times bottom, so that'll just give you 1 over 2 x squared. Alright, so with this question, I actually tried it already earlier, and it's not a nice question, as in, it doesn't give you a nice, satisfying answer at the end, like 2. It's just weird. It's just a bunch of exponent rules and stuff, but let me try explain it and make it as easy as possible for you. So what I notice is that I typically want something I want to somehow be able to maybe cancel this out. So I notice that if I take these two, and if I take out a common factor of x, and if I take out let me first go break it up. So xn, x2, xn, x1, minus xn times x minus 1. So I've just broken up all of the top parts. Now, if I look at this term and this term, I can take out a common factor of xn, and then I get x squared minus 1 left over. Because remember, this one here would have a 1 left over. Then, if I look at these two, I'm going to take out a common factor of xn as well, and then you're left with x minus 1, or x minus x to the minus 1. Okay, now this is looking good. I can't cancel yet though, because this is 2 terms at the top. You can't just cancel like that. Right, now if I look at this, x minus x to the minus 1, that is the same as x minus 1 over x. Now, you could think of this as x over 1. If you wanted to simplify this, you could get a common denominator. What would the common denominator be? It would be x. So then you would multiply this by x and this by x, because what you do to the bottom, you do to the top. And then you'd be left with x squared over x minus 1 over x. And then because these are the same, you can just put them together. You can't cancel them. It's not an equation. And then you would have that. And so there I'm seeing that x squared minus 1 popping up again. That whole part changes to x squared minus 1 over x. And then at the bottom you just have that. Right, now I'm going to take this x out to the front. So it's going to end up going like that. Okay, but let's do it over here. So you're going to get xn x squared minus 1 plus xn over x, and then you're left with x squared minus 1. There we go. Now you can cancel boom, boom, boom. And so all that we're left with now is xn plus xn over x, and then these two can be combined again. Remember that this is a 1, so it can be rewritten as x to the n plus. Now this part, you minus the exponents, so it becomes x to the n minus 1. And that's the answer. Not a nice question. I don't like it at all. It's not very satisfying. There are other ways you could have done this question. Some ways are much longer than others. I think this is probably the shortest way, but yeah, not nice. Simplify without using a calculator. Right, so a few little things you need to understand. If you have a square root multiplied by another square root, you are allowed to then just multiply the two things inside the square root. So you see this big square root and you see this big square root. I'm going to make it one big square root and then just put whatever's inside that. Okay? Then what I'm going to do is I'm going to go FOIL these brackets out. So like a times a times that times that, and that times that. So that's going to give a times a is a squared. Now when you multiply these two, that's just going to give negative a square root 2a minus 1. And then when you multiply these two, it just gives the positive of that. And then here we're going to use this rule once again, where if you're multiplying, let me just quickly explain. If you multiply, as we said, if you multiply two square roots together, you can just do that. But if the two things that you are multiplying are exactly the same, then have a look what happens. A times a becomes a squared, but then what does the square root of a squared become? It becomes a. So if that's the first rule, then this is a second rule. When the two things that you are multiplying together inside the square root are exactly the same, the final answer just becomes that thing without the square root. So if you multiply square root of 2a minus 1 with the square root of 2a minus 1, the final answer actually just becomes 2a minus 1. So when I multiply these two together, the answer becomes 2a minus 1. But I must put that in a bracket because this is a negative. Okay, now it's going to be a lot better now because these two terms cancel out. See that? They cancel because here we've got a negative and here we've got the positive version. So all that we now have is a squared from here, and then here we're just going to say minus 2a plus 1. Now that can factorize as a minus 1, which is the same as a minus 1 squared. Now when you have a square root and a square, they will cancel each other out. And so you'll just be left with a minus 1. This is quite an interesting question because we're going to solve for 3 unknowns with only one equation. Now normally in maths, when you have 3 unknowns, you would need 3 equations. Just like we always get told when we have 2 unknowns, we need 2 equations. But there's going to be something interesting we can most likely do. So let's see. And then I don't know what's up with this random bracket over here. It's quite weird. But anyways, what I'm going to do first is I'm going to divide this onto the other side. So we're going to end up with x plus y root z equals to minus 3 plus the root of 2 over 1 minus root 2. Okay. Now, whenever we have a situation like this, maybe you've done this in class with your teacher where you rationalize a denominator. What that means is whenever you have a denominator that has a square root, we can change that by multiplying the top and the bottom by the conjugate. The conjugate is where you change the sign. Okay, so we do top and bottom. Why is this allowed in maths? Because what does this actually give you? Well, if you have something divided by itself, it actually just gives you a 1. So if we are multiplying this expression by 1, we're not actually changing it. Because if you take a number like 5 and you multiply it by 1, it still gives you 5. So we're allowed to do this mathematically, okay? But the reason we do it is it makes everything look a lot nicer once we've simplified. You'll see now. So at the top, I'm going to FOIL. So I'm going to go, so you can think of it like that. So it's going to become minus 3 plus minus 3 square root 2 plus square root 2 plus the square root of 4. And then at the bottom, here's where it gets really nice. You're going to FOIL. You can imagine that we've got brackets. So it's going to become 1 plus the root of 2 minus the root of 2 minus the root of 4. No, you can't cancel things like this out because we've got more than one term at the top and more than one term at the bottom. What's really nice now, though, is that these two are going to cancel. And that's the whole point of rationalizing the denominator. You're getting rid of the square roots in the denominator. And this is just going to become the number 2. So I'm going to change these to the number 2 and the number 2. So here we can say minus 3 plus 2, which is minus 1. And then here we've got minus 3 square root 2 plus 1 square root 2, which would be minus 2 square root 2. And then at the bottom, we're going to have these two cancelling, and you're just left with 1 minus 2, which is negative 1. And now I'm just going to divide that by negative 1 and that by negative 1. And so you end up with positive 1 plus 2 square root 2. And now what we can do is just literally copy. So x must be this, y must be that. Let me do it in different colors. Y must be that, and then z must be that. So it all looks, you can see that it all looks exactly the same on the left and the right. And so we can then say, therefore, x is 1, y is 2, and z is 2. A lot of learners completely freak out when they see paper 2 content like trigonometry stuff in a paper 1 or vice versa. Guys, they will often do that. Also in matric, they're going to do that quite a lot. Don't panic. It's usually something very straightforward. And look at this. They're only 1 mark questions. So, given the pattern tan, sin, sin, cos. Oh, sorry. It's tan, sin, sin, cos. Okay. Explain how each term is found from the previous term. Okay, so how do we go from tan to sin, and then from sin to sin cos? Well, remember, tan is sin over cos. All that they're actually doing is, for this one, they're multiplying it by cos. So if you multiply by cos, then those end up cancelling. So you end up getting just sin. And then if you take this sin and multiply it by cos, you end up getting that. So all that they're doing each time is they're just multiplying by cos, multiplying by cos, multiplying by cos. They're just multiplying by cos each time. So we can just say multiply, or let's say multiply previous term by cos. Okay, write down the fourth term. Well, the fourth term, if you had to multiply this by cos, it would end up becoming sin x cos squared x. So sin x cos squared x. Let me just explain that again. If you have cos x and then you're multiplying that by sin x cos x, because some learners might say, but Kevin, why doesn't it go to the sin and the cos? Remember, this is one term. It's like multiplying x with xy. It just becomes x squared y. If there was a plus or a minus in the middle, yes, well then it would go there and it would go there. You see, that's the difference. Given the pattern, okay, minus 1, 2, 5, and 8. So you can see that each time we are adding 3. So it's a linear pattern. Okay. Determine an expression for the nth term. So in grade 11, we learn about this formula over here. In grade 12, we start learning about this one. Okay, so if any grade 12s are watching this, yep, you could use that one for sure. So we know that A is the difference if you're using the grade 11 formula, and then B is term 0. Okay, so the difference each time is 3n. Now, what is term 0? Well, this is term 1. So what would the term just before that be? Well, that would be minus 4, because minus 4 plus 3 would give you minus 1. So it's going to be a minus 4 over here. If you don't like working out term 0, then the other option is you do the following. I then want you to, you go and choose any one of these. Let's say you chose this one. So that is term 3. Term 3. So term 3 has a value of 5. So you fill in 5 for the term value and 3 for the position, because it's position number 3. And then you're going to get 5 equals to 9 plus b. And then if you take the 9 over, you get minus 4, just like we said over there. Okay, so we have a formula, Tn equals to 3n minus 4. So the next question says, which term will have a value of 161? So you put the 161 over there, so you say 161, and then you take the 4 over, and so you get 165. You then divide both sides by 3, and you get n as 55. In the diagram below, the first 3 figures in a pattern that Mary is investigating are shown. Determine the total number of squares for figure 5. Okay, so how many squares do we see here? Well, I see 1 square over there. Then for this one, I see 1, 2, 3, 4 squares. And then 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so it's 9 squares over here. Then 4 squares over here. And then 1 square. So can you see that all that it is, this is just the same as 1 to the power of 2. This is the same as 2 to the power of 2. This is the same as 3 to the power of 2. So figure 5 would be 5 to the power of 2, which is 25 squares. You understand? This one here is the same as 2 to the power of 2, which is 4. And then this one is 3 to the power of 2, which is 9. And then figure 5 would just be 5 to the power of 2, which is 25. Now it says how many dots will there be in figure 7. Okay, so now we're going to go look at the dots and see what the formula is. So here we've got 4 dots. Here we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 dots. Here we've got 1, 2, 3, 4, 8, 12, 16 dots. Okay, so this is the same as 2 to the power of 2. This is the same as 3 to the power of 2. And this is the same as 4 to the power of 2. So now we can see that figure 1 becomes a 2. Figure 2, they're using a 3. Figure 3, they're using a 4. So figure 7 would be an 8 to the power of 2, which is 64. Okay? And now this last one says, considering the nth figure, show that an expression for the number of dots can be written as n plus 1 to the power of 2. Okay, so let's go make let's go write out. So we've got 4, 9, 16. Okay, now if we had to just carry on one more, so we know that we said that this was 2 to the power of 2, 3 to the power of 2, 4 to the power of 2, and then 5 to the power of 2, so it would be 25. This is quadratic. Let me show you. If you look at the difference there, that's 5. If you look at the difference there, that is 7. And if you look at the difference there, that is 9. So if we then go further, 2 and 2. Now we know how to make a formula for quadratics. We use 2a over here, 3a plus b over here, and then this one is always a plus b plus c. And so we could go work out a now, or we know that the original equation of these things always goes like this. So we could go work out a as 1. So a is 1. Then we could say 3a plus b must be equal to 5, but we already know that a is 1 and so b would end up being 2. And then a plus b plus c is 4. But we already know that a is 1, b is 2. And so if we had to solve for c, we would get 1. So we could fill in our formula now, a as 1, b as 2, and then c is 1. If you had to factorize this, you would actually realize that it can factorize as n plus 1, which is the same as n plus 1 to the power of 2. An athlete runs along a straight road. His distance is given by the following equation. Okay, so all that this table gives us is that they give us the time. So at 1 second, he ran 17 meters. At T2, he ran 10 meters. So it's a pretty straightforward table. The first question says, determine the value of R and S. Well, if you look at these numbers, you're going to notice that they are actually quadratic, where the second difference is constant. To go from 17 to 10, the difference is minus 7. To go from 10 to 5, the difference is minus 5. And then to go from 5 to 2, you have to subtract 3. Then to go from minus 7 to minus 5, you're actually going to say it's actually going to be plus 2, and then plus 2. If some of you struggle to find these numbers, the way you work it out, you always take the one on the right minus the one on the left. So minus 3 minus 5 will give you positive 2. If you rather wanted to do it over here, you always take the one on the right minus the one on the left. So minus 5 minus 7, it ends up becoming a plus 7, and so you end up getting a 2. So now if we had to just carry on, we could eventually work out what R must be, because that's the next one, and then S. So if you look at these numbers, 7, 5, 3, the next one would be minus 1. And then it would actually become positive 1. You see how we're adding 2 each time, adding 2, adding 2. Okay, now if you want to, so if you look at the 17, and then if you add negative 7, it becomes 10. So because you're adding a negative number, you're subtracting. 10 add negative 5 gives you 5. And then if we keep going, 5 add negative 3 gives you 2. Now 2, if you add negative 1, you would end up getting 1. And then 1, if you add 1, you end up getting 2. So R is going to be minus 1, and S is going to be 2. Okay, and the next question says, determine the values of A, B, and C. So A, B, and C are here. So this is just a normal quadratic kind of question where we know that this is always equal to 2A. This is always 3A plus B. And then this part's always A plus B plus C. And so if we say 2A is equal to 2, then A must be 1. If we say 3A plus B must be minus 7, but we already know that A is 1, then if we solve for B, we should eventually get minus 10. Then if we say A plus B plus C must be equal to 17, we fill in A as 1, we fill in B as minus 10, and then if we had to go work out C, you should eventually end up with 26. So if we then fill in the formula to make sure that it's all correct, remember I always tell you, you must just you must double check it, because sometimes you can make a little mistake over here. So how do we check it? Well, what I do is I'll typically choose like this one over here, so I know that that is position 3. So I'll go calculate position 3, and I hope that I get 5. If I get 5, then I know that my formula is working correctly. Okay, and if you go work this out, you get 5. Cool, so we know we've done it correctly. So we know that A is now 1, B is minus 10, and C is 26. This one says, how far is the athlete when n is 8? That's a super easy question. You're literally just going to go take the formula that we found, and we are going to go fill in 8. So like that. And then if you had to work this out, we get 10 meters. Okay, 10 meters over here. Last one says, Michaela claims that the pattern will have a minimum value. Jack claims that the pattern will not have a minimum value. Who is correct? Okay, so it's definitely going to be Michaela. Let me explain why and show you why. So we know that this whole question is, this is the equation that is giving us these numbers, right? Now, if I asked you what kind of graph is that? Obviously, we normally use y and x. So what kind of graph is that? Is it a hyperbola, exponential, straight line, parabola? It's a parabola. Now, because this term over here in front of the x squared, because that is a positive number, your parabola is going to be a positive smiley face, like that. If it was a negative, then it would go like that. So if it was negative, it would have a maximum, but because it's a positive, it's going to have a minimum value. All right, and that is just the turning point. Now, if we had to go calculate that, how do we normally calculate a turning point? We use x equals to minus b over 2a. You can use that over here as well. We can just say n equals to minus b over 2a, and we can just use it here. A is there, B is there, and C is there. And so we're just going to say minus B, minus 10, and then A is 1, and this gives you a value of 5. That doesn't mean the minimum value is 5. That means that the minimum is when we are at position number 5, and we already know that that had an R value of minus 1. And so is that not the smallest value that we've seen? Look here, 17, 10, 5, 2, minus 1. Then it starts going up again, just like a parabola would have done. Check here, 17, 10, 5, 2, minus 1. And then it starts going up again. 2 probably would have gone, yeah, it just keeps increasing. So the minimum is at this point over here. And we can see that it's a minimum value. So how would you do this in an exam? Well, you would explain to them that this over here, you could literally say, has the shape of a parabola. And because the a value is bigger than 0, it'll cause the parabola to have a minimum. And then you could also go do this calculation and then show that the minimum value is minus 1. After 2 years, a cell phone is worth 1/3 of its original value. Using the reducing balance method, calculate the annual rate of depreciation. Very easy, straightforward. We know that in life, the items that you own will become less in value because of something called depreciation. They can either become less in value as a straight line like that, or they can become less in value by going like that. So this one is called the straight line method, and this one is the reducing balance. Okay, so they've asked us to use this one. Now, this is like simple interest, where we used to use this formula over here, remember? But now, because we're going down, we're going to say minus, and then this is like compound interest, where we normally go like that, but because it's going down, we rather put it as a minus. There we go. Okay, they've asked us to use the reducing balance method, so we're going to use this formula over here. Now, always remember, the p value is the start, the a value is the end. So we don't know what the starting value is, we don't even know what the ending value is. So we're going to say let the starting value be x. Let's just let the starting value be x. Then the ending value would be 1/3 of that. So it would be 1/3 x. So you're going to say 1/3 x equals to x, 1 minus I, and then how many years? 2 years. Okay, we're not doing compounding monthly or anything, so we're not going to put a 12 there or anything like that. No, we're just going to leave it like that. Now, these x's, you see how they are on both sides? We're just going to cancel those out. And so we end up with 1/3 equals to 1 minus I to the power of 2. So how would we solve this now? Now we take the square root on both sides. Now normally we would say plus minus over here, but with these kind of interest rate questions, we don't. You can just leave it like that. And if we then, okay, so that square root gets rid of that 2, so you end up with 1 minus I equals to the square root of 1/3. Then I'm going to take this I over to the left, and then I'm going to bring the square root 1/3 to the right. And then I'm going to multiply whatever this answer is by 100 so that it goes back to a percentage. And what you should get is 42.26%. Cole's car wash is saving for new equipment. Cole invests 10,000 Rand at that interest rate over there, compounded monthly. Calculate what the effective interest rate will be. Okay, so to calculate the effective interest rate, we just use the 1 plus I effective formula. So let me just write that a bit bigger. It's like that. And then here you're just going to say 1 plus I nominal over n to the power of n. So your effective is like your yearly, and then your nominal is like your monthly, quarterly, all those different things, semi-annually, whatever. So we're trying to calculate this one. So that is the unknown. So we're going to say 1 plus I effective, and then 1 plus. Now your nominal is 7.5%. So that's 0.075. And then they compounding monthly. So these two numbers always have to match. Even if the question talks about 3 years or 5 years or 10 years, you're not going to say times 3 times 5. With this formula, we're only looking at 1 year. So these two numbers will always be the same in this formula only. Okay, I'm not talking about questions where it's like 3 years and we use those other formulas. Specifically this formula, these two numbers are always the same. Okay, you don't say 12 times 2, 12 times 3, none of that. Right, so if you had to try solve this now, I get quite lazy, so I don't want to use my calculator. Like, I don't want to have to type anything in just yet. So I take this 1 over, so I end up getting 1 plus 0.075 over 12 to the 12 minus 1. Now I will go type that in on my calculator, and I will also, whatever my calculator gives me, before I even round off, I'm going to multiply by 100 so that I can convert it to a percentage, and then I will round off. And there we get 7.76%. Your effective interest rate will always be a little bit higher than your nominal interest rate. So 7.76. But if you got an answer here of like 37 or 40, that's way too high. Something's gone wrong. Cole deposited 10,000 Rand. At the end of the first year, the interest rate changes to that. 6 months later, he deposits another 5,000 Rand. If Cole requires 17,000, will he have sufficient funds after 3 years? Okay, so timeline. So the timeline can start here at T0, and they tell us that Cole deposits 10,000 Rand. So I'm going to show that there's 10,000 Rand going in there. At the end of the first year, the interest rate changes to 7.8, and I'll take care of the interest rate just now. 6 months later, okay, wait, listen carefully. At the end of the first year, okay, so at T1, something happens. And then 6 months after that, okay, so 6 months is going to be half a year. So that'll be half a year from T1. So it'll be T1,5. We are at 1.5 years over here. What does this guy do? He deposits 5,000 Rand. Okay. Right. And then if Cole requires, will he have sufficient funds at the end of the 3 years? So at T3, we are going to calculate how much money he has altogether. And we hope, for his sake, that it's 17,000 Rand or more. Let's see. Now the interest rate. The interest rate for the first year is going to be the original 7.5% monthly. Okay. Then they say at the end of the first year, so over here, the interest rate changes to 7.8% compounded quarterly, and it stays like that all the way to the end. So that's going to be 7.8% quarterly. Let's actually do that in a different color. There, and that's going to be 7.8% quarterly. All right, so very easy. If you've watched my videos on this before, it's a simple strategy of what we're going to do. I want you to go find the first amount that he puts in. It's this one over here. And I want you to completely forget about everything else. And all you're going to do is you're going to take this and you're going to compound it all the way to the end. Okay, so we're going to just say 10,000. Then we're going to use the compound formula. So 1 plus 0.075. That's being compounded monthly. How long did that one last for? Only 1 year, so we're just going to put a 12 over there. And then the interest rate changes to the blue one. So let's go change the interest rate now. So it now becomes 1 plus 0.078. I'm actually going to run out of space over here. Oh, no, it's fine. And that's going to be compounded quarterly. And that goes for that goes for 2 years. For 2 years from T1 to T3. So you're going to say 2 times 4, which is 8. Okay, then you're going to normally, if I had space, you would say plus over here. And now all that you're going to do is you're just going to go to the next value. So now we're done with this one. Now we look at this one. So we're going to say plus 5,000. And this one only goes from here to here. So this one doesn't use the green interest rate. It only uses the blue interest rate. So we're just going to go straight to that one. Now be careful, it's only going to go from 1.5 years to 3 years. So that's 1.5 years. So you're going to say 1.5 times 4, which is 6. So you're just going to put a 6 over there. And that's it. You go type everything in on your calculator. Cole, we're holding thumbs for you, buddy. There we go. Most of the times they make these questions very positive. The person always ends up getting what they want. 191.03. So let's answer their question. Cole needs 17,000 Rand. Will he have sufficient funds? Therefore, yes. Sufficient. 2 friends receive an amount of 6,000 Rand each to invest for a period of 5 years. They invest the money as follows. Sorry, followers, my bad. Mervyn, 8.5% per annum simple interest at the end of 5 years. Mervyn will receive a bonus of exactly 5% of the principal amount. Haley rather does 8% compounded quarterly. Who will have a larger investment after 5 years? Justify with appropriate calculations. This is free marks, they're just giving away marks here. This is super easy. So let's go work it out. Okay, so Mervyn, let's just write this down. Whoops, what happened there? Okay, so Mervyn has 6,000 Rand and he's going to invest it using simple interest. So remember the simple interest formula goes like this. And so let's see, 6,000 Rand. Interest rate is 8.5%. And it's not compounded monthly or anything like that. So we're just going to say 0.085. And then it's going to be 5 years. Okay. And if we calculate what good old Mervyn is going to have after 5 years, it will be 8,550. And then they say that they're also going to give him, Mervyn will receive a bonus of exactly 5% of the principal amount. The principal amount is the starting amount, which is the p-value. So if we had to go work out 5% of 6,000, that would give us 300 Rand. So he gets like a little 300 Rand bonus. And so if we say 8,550 plus 300, Mervs is going to be left with 8,850 Rand. Okay, now Haley, she is going to use compound. Okay. And so she also starts with 6,000 Rand. Her interest rate is 8%, but it's compounded quarterly. And so we're going to say also 5 years, but we're going to say 5 times 4. And so if you had to go work this all out, we end up with 8,915 Rand and 68 cents. So who has more money? Who will have a large investment? Haley has the larger investment. Mervyn, unlucky brother. Oh, guys, I'm busy cracking myself up here. Like, I'm just thinking back when I was in primary school and how, the kids would like if they just caught you staring at someone eating, or if they caught you asking someone for money for food, then they would all be like, Kevin is hungry. So I'm just laughing at Mervyn now. Shame, Mervyn. Unlucky. You thought that your 300 Rand bonus was gonna let you win. Next time. Wow, guys, I need to like get out the house, I think. Here they give us an equation, a times bx, okay? That's not a point b. It's not like a decimal number. It's a multiplied by b to the x, or something like that, okay? A is not 0. They said that P is a point on the graph. Okay, write down the domain of F. So this, we can see the domain is going to go, the domain is all the X values. So it's going to go all the way to the right, and it would keep going all the way to the left. So we could just say that X is an element of all real numbers. You could also say something like X is an element, from minus infinity to positive infinity. Or you could say X is bigger than minus infinity, smaller than infinity. Write down the equation of the asymptote. So the asymptote, we would normally have seen it over here. So if you don't see it, it means that it's on the x-axis. Whoa, Kev. It's on the x-axis itself. So the equation of that line is, the x-axis is called the y equals to 0 line, because everywhere on this line, y is 0. Okay, if b is 3 over 4, thank you very much, calculate the value of a. Okay, so they've given us b. That's nice. So we can just remember that this is y. So we've got a point, so we can fill in 144 as the y. The x is 2. And I would just go type this on my calculator. It's going to give 9 over 16. So we can say 9 over 16a. You can then divide both sides by 9 over 16, and you should end up with 256. Okay, so A is going to be 256. This one says, the graph of G is obtained when you reflect the graph of F in the y-axis. Write down G's equation. So, very easy. They said that G is the equation that you get when you take F. Okay, so you take F and you reflect it in the y-axis. When you reflect something in a y-axis, it goes like this. So this point would end up going over there. This point would end up going over there. You get it. Like if I just have a basic y and x, and I have a point over here, let's say the coordinates are -1 and 1, or let's go -1 and 2. When you reflect it across the y-axis, it becomes +1, but the y value still stays 2. So the x values become the negative, or the opposite of what they were. If you had a point that was over here at maybe 2 and -3, then when you reflect it over, it would go to -2, but the y would still stay as it is. Only the x value changes. So the x value will become the negative of what it was, or the opposite of what it was. So the way that you do that now is you're going to say that g of x is going to be the same as the equation of f of x, which is a is 256, b is 3 over 4. Remember, you can't multiply these two together because there is an exponent. But now instead of saying x over here, you are going to say minus x, because the x values become the opposite of what they were. And that's it. They will accept the answer just like that. If, however, you are a student that doesn't like to leave your answer with negative exponents, then what you need to do is the following. But you can leave it like that. It's perfectly fine. I even looked at the memo. They accept it, no problem. But what you would do if you prefer to have positive exponents is you can think of the minus x as -1 times x. So what does -1 do to this? Well, it should flip it upside down like that. That's what the -1 does. And then you can just say x. So you can write your answer like this or like that. Both are accepted. I'm just going to use the one that has not been simplified. Okay. Now, oh, and obviously you would say g of x equals to that. Okay, is g, which is this new one, an increasing or decreasing function? Well, let's look at this function. Is that increasing or decreasing? Well, that is going downhill. Can you see that? So that is decreasing. But now if this point had to end up going there, and this point ended up going there, then you would end up getting something like that, which is now an increasing function because it's going upwards. So we would say increasing. They want a reason. You could say that as x increases, g of x increases. What does that mean? As you go from left to right, the x values are becoming larger. So you're increasing the x values. And as we are going from left to right, we can see that the y values, sorry, the graph was there. We can see that the y values are also increasing. Okay. Whereas with this one, as the x values are increasing when you're going from left to right, we can see the y values are decreasing. Okay, and then this one, it looks horrible. Prove that this minus this is going to be the same as that minus that for all values of x. Okay. What does that even mean? Okay, well, let's see what we can do. I'm going to go work on this side over here. So I'm going to go work on f of x squared minus f of minus x squared. Okay, and let's see what that gives us. So you take the equation of f, which is 256 times 3 over 4 to the x, and then you square that. Okay, and then you minus the same thing, but instead of having x, you're going to have minus x. Okay, so let's simplify that and see what we can get. So this 2 ends up going there, and it's also going to end up going there. So you're going to end up getting 256 to the power of 2, and then 3 over 4 to the power of 2x, and then that's minus, now the same thing over here, 256 to the power of 2, and then 3 over 4 to the negative 2x. Okay. Right, I don't really see what else we can do there. So let's now go and work on this side. So that's now a times f of 2x minus a times f of minus 2x. Okay, so a is 256, and then f, so we're going to take the graph of f now, which is also 256 times 3 over 4. But instead of saying, they want us to replace the x with 2x, so we're going to say 2x like that, okay? And then they want us to minus 256, and then 256, 3 over 4 to the negative 2x. Okay, so if we then simplify this, this will give us 256 to the power of 2, and then 3 over 4 to the 2x. And then this one will give us 256 to the power of 2, and then 3 over 4 to the negative 2x, which is exactly the same as that. So I guess we've proved it. Right, and I went and double checked on the memo. It's exactly what they did. They said left-hand side, and then they said right-hand side, and then they said, therefore, left-hand side is the same as the right-hand side. You see how we're getting exactly the same over there and over there. What a weird question. Looks scary, but was actually pretty straightforward. Okay, so here in this question, they give us the equation of a hyperbola, and the first question says the equation of the asymptotes. Let's look at the most basic hyperbola that you can get. It would just be something like this, and it would look like there's no asymptotes, but in fact, the asymptotes are on the x-axis itself, so you can't see it, so that it would be on the x-axis, and the other one would be here on the y-axis. So a hyperbola always has two asymptotes, okay? So when they give you the equation, you can actually easily work out where the asymptotes are. This one over here means that the graph has been moved down by 1 unit. So the asymptote will now be down by 1 unit, where y is minus 1. So you call this the y equals to minus 1 equation. And then what does this do to a graph? Does that move a graph left or right? Well, that actually moves a graph left by 4 units. So you're going to get over here where x is at minus 4. So you call this the x equals to minus 4 asymptote. And so the two answers would be y equals to -1 and x equals to -4. So keep that in mind. You can get the equations of the asymptotes from the graph, from the equation of the hyperbola. This question says calculate the intercepts with the axes. So they want the x and the y intercept. To find the x-intercept, you make y 0. So you're going to say 0 equals to 2 over x plus 4, take away 1. I'm going to take the 1 over to the other side. And then you can imagine that it's 1 over 1, and then you can just do cross multiplication. And so you end up with 1 multiplied by x plus 4 on the left, and 2 multiplied by 1 on the right. So it becomes x plus 4 equals to 2, and so x is going to be 2 minus 4, which is -2. So you're going to say -2 and 0 for the x-intercept. Then to find a y-intercept, you make x 0. This is even easier. You're then just going to say y equals to 2 over 0 plus 4 minus 1, and that would end up giving you -1/2. Okay, so that's going to be x 0 and y is -1/2. 7.3 says sketch the graph. Okay, well, I've already got the asymptotes in. So to find the x-intercept is going to be -2. If this is -4, then -2 would be over there. And then let's just get rid of these little dots over here. Okay, and y is -1/2. So if this dotted line is -1, then -1/2 would be somewhere there. Okay, so you're going to get a graph that's going to go something like that. But we know that a hyperbola always comes in pairs of 2. So if the 1 is in this quadrant, then the other one would have to be over there. It's always diagonally opposite from each other. Okay, now on a graph, you would have to label everything. So we've labeled the asymptotes, but let's also label the intercepts. So I'm running out of space, but you would say 0 -1/2 for that one. And then for this one over here, you would say -2 and 0. Okay, so we've done 7.1 up to 7.3. 7.4, write down the coordinate of the image of the x-intercept if it is reflected across the axis of symmetry y equals to -x minus 5. Okay, so we know that all hyperbolas have axes of symmetry. They've got two. They've got one that goes through where the asymptotes intersect like that, and then they've got another one that goes like that. Okay? Now, they have asked us to they've asked us to look at the axis of symmetry that has the negative gradient. That's this one over here. Okay? So let's get rid of that one. So this one's equation is obviously that. Let's double check. We know that the gradient for the symmetry lines of hyperbolas are always going to be +1 for this one. There, the gradient is always +1, and this one, the gradient is always -1. So we know that the gradient is -1. Then, to find c, you would plug in a point on that line, which is this one over here. Now, what would the coordinates be? Well, it's easy. We know that the x value is -4, and we know that the y value is -1 at that point over there. So we can plug that in. So y is -1 and x is -4. And so you end up with -1 equals to 4 plus c. And if you had to get c by itself, it's -5. Okay, so this is the correct line that they've given us. I just wanted to make sure. And so what they are now asking, write down the coordinates of the image of the x-intercept if it is reflected across the axis of symmetry. So if they take this and they go to there, they want to know what is that coordinate going to be. Oh, well, it's very simple. We know the coordinates here, and we know the coordinates here, and we know that it would be the midpoint. This point here would be the midpoint from here to here. That green dot over there, that is the midpoint. So we could just use the midpoint formula in reverse. So we know that midpoint is equal to the x values added together and then divided by 2. and the same with the y values. So we know that we don't know what this x value is, and we don't know what its y value is. So we can just pretend that let's pretend you did know what that was. You would say x, and then you would plus this one's x value, and then you would divide by 2. And what should the answer be? Well, the x answer for the midpoint is minus 4, so you can put minus 4 over here. And so you're going to end up getting x minus 2 over 2 equals to minus 4. You can think of it as minus 4 over 1. You can then cross multiply. So you're going to end up getting x minus 2 equals to minus 8. And so x would end up being minus 6. So this x value is going to be minus 6. And then for the y values, we're going to do the exact same approach. We're going to say that the y value of this point, which we don't know, so we just say y, plus the y value of this point, which is 0, over 2, and the answer for the midpoint should be minus 1. We can use cross multiplication again. You would eventually end up with y equals to negative 2. Okay, so now we have the coordinates as minus 6, minus 2. This question over here says, write down the range of y equals to the negative of f of x. Okay, so let's just go look at, forget about the negative for now. Let's just look at this graph. What is its range? Well, I've explained this to you guys before, that for the range and domain of a hyperbola is very easy. How to do domain and range of a hyperbola. Okay, so for the domain, you can say that x can be all real numbers except for the asymptote. So don't let it be equal to the asymptote. So in this one, you would say x can't be minus 4. For the range, you would say that y can be absolutely anything, but just don't let it be equal to the y asymptote, or the, let's actually say that horizontal asymptote. And then this one is the vertical asymptote. Let me explain. If you look at the x values of this graph, we can see that x can be absolutely anything. You see how it goes all the way to the left, and if we had to go all the way to the right, the only place that we don't see the yellow is on this dotted line, because the graph cannot exist at that point, and that's why I'm saying x can be anything, but it just cannot be the vertical asymptote. And then for range, you can see that the graph can go all the way down, as far down as it likes, and it can go all the way up, as high up as it needs to go, but it just, the only place where we don't see green is across this dotted line. So that's why we're saying that for the range of a hyperbola, it can be all the real numbers, but it just can't be the horizontal asymptote. So let's go work out let's forget about that negative, and let's just go work out the range of this graph. So the range of f of x would just be y can be anything except it cannot be minus 1, because of that minus 1 over there. Now, if we instead you did the negative, all that negative does is it just flips the graph upside down. And so what would happen is that this point over here, if that also flips, then it would end up going, instead of being down here at y equals to minus 1, it would be flipped over, and it would now run up here at y equals to positive 1. So to answer this question, we'll just say that y can be anything, but y simply cannot be equal to positive 1. Okay, and this last question. Describe in words the transformation if you go from f to g, if you end up getting that over there. Okay, so if you look at the original equation for f, it is 2 over x plus 4, take away 1. Whereas this new equation, g of x, is going to be minus 2 over x minus 4 minus 1. Check this out. All that they've actually done is they took the equation of f and they changed the x to a negative. Now let me explain. If you then, so you see how we've just put a negative in front of the x. Okay, remember that for later, or just now when we talk about that. But I've just gone and put a negative in front of the x. If I then had to take out the negative as a common factor, what would I get here? X minus 4, right? And then that still stays minus 1. I can then put that negative, I can keep it at the bottom, but I'm also allowed to write it at the top. Mathematically, that's the same. So then at the bottom, we now have that. And that is exactly what we have over here. So how did I go from having this to getting to that? Or what did we actually do? You simply had to change the x value. So what is that mathematically if you're just changing the x value to the opposite of what it was? If it was positive, you're making it negative, and if it was negative, you're now making it positive. What is that? Is it a reflection, or what is it? Well, that is actually a reflection across the y-axis. Let me explain. If you have a random point over here, for example, let's say the coordinates are -2 and 3. If you reflect it across the y-axis, what does the new coordinate become? It becomes 2, but then the 3 stays 3. And if you had a point over here, let's say the coordinate was 1 and -4, if you go that way, well then what does the new coordinate become? -1, but it still stays -4. So whenever you reflect across a y-axis, the x changes. So because we went to go from here to here, all that we actually had to do was just put a negative in front of the x. That is a reflection over the y-axis. So we can say reflection over, not ovary, Kevin, not doing biology, reflection over y-axis. Sketched below is a parabola and a straight line. And, I saw it immediately. This dotted line, they like to talk about minimums and maximums. Okay. So, they give us the straight line equation, a third x minus 1. Okay. T is the turning point. J cuts the y-axis at 6 and the x-axis at R. Okay, so they haven't filled that in for us. So, R is -1. Okay. J and V is a point such that VW is parallel to the y-axis. Okay. And first question for 3 marks. Show that the equation of the parabola can be written as that. Okay, so remember that there are only 2 ways to work out, or 2 main ways to work out the equation of a parabola. Either they give you the turning point. If they give you the turning point, then you're going to use this formula. I'm going to run out of space there. You're going to use this one over here, okay? And then if they give you the 2x intercept, then you would rather use this. Okay, so they've given us the turning point, so we're going to go use this equation. Some teachers will even put a plus here. It doesn't matter. It really doesn't matter. You've got to understand how to plug the values into the formula. That's the part that's important. So, we don't know what A is, but if you look at the turning point, can you see that this is a turning point that has been, if you think about a normal parabola from like grade 9 and 10 goes like that, right through the origin. So how do you end up going there? Well, it must have moved 1 place to the right, so we're going to say x minus 1. And it must have moved 8 units up to end up over there, okay? And that's going to be +8. How did it end up upside down? Well, that's obviously going to be the a value, and that's going to end up being negative when we solve it. Okay, now the next thing you do is you go find any other point on that graph. So you could use this one, or you could use this one. I'm going to use the 6. So remember that that means that the x there is 0 and the y is 6. So you're going to put a 6 there and a 0 at the x. Okay, a very common mistake that I see is learners combine all of this to become 1. You can't. Remember that this a is only with this part. So this part here, you're actually going to take that to the left. Okay, so you're going to, I see that mistake quite often. So 6 minus 8, and then a, and then if you type this on your calculator, it just actually becomes a 1. Make sure you use a bracket. And so you end up with -2 equals to a. Okay, so we have a. Fantastic. And look, it is negative. Just what we expected, because we said that the graph has been flipped upside down. Now, to get it to look like that, we're just going to go multiply out. We're going to say x minus 1, x minus 1. And then I'm going to go multiply the x minus 1s and the x minus 1s together. That's going to be x squared minus x plus 1, and then plus 8. And then that's going to be minus 2x squared plus 2x plus 2x minus 2 plus 8. And so y is going to be minus 2x squared plus 4x plus 6. And that's exactly what they want. Calculate the average gradient between x equals to 1 and x equals to 3 on the graph of J. Okay, so don't worry about the word average, just go work out the gradient. There is a reason why they're using the word average, but it doesn't change how you're going to calculate it. y2 minus y1 over x2 minus x1. So they're saying at the place where x is 1, okay, we already have x equals to 1. So we know that that coordinate is 1 and 8. And then x equals to 3. Okay, well, that would be exactly over there. How do I know that? Well, if you look here, what is the x value of that line? The x value of that line is 1. What is the distance to there? Well, what is the distance if you go from 1 to minus 1? Well, that would be 2 units. So it would have to be exactly the same on the other side. So if this already is a 1, and you add 2 units, it would give you 3. So the other x-intercept has to be 3 and 0. And then this one here we know is minus 1 and 0. If you didn't think about that in a test or an exam, it doesn't matter because you would have the equation. And so if you wanted to go find x is 3, you could go plug the 3 into the equation and you would get the y value and it would be 0. And then that would help you to realize, oh, it's the x-intercept. Okay, so now we can just go use the gradient between this point and this point. And maybe some of you, when you saw x equals to 1, you didn't think, wait, does that mean the y value is 8? I'm not sure, it feels a bit weird. Doesn't matter, you can then go plug that 1 into the place of x, and you would get 8. And then in your test, you'd be like, oh yes, silly Billy, of course it is. All right, so let's go work it out. 8 minus 0, and then 1 minus 3, and that's going to eventually give us minus 4. So the gradient will be minus 4. This one says, calculate the coordinates of P, which is the place where the two equations intersect. Guys, that's easy, marks. I've never really encountered a lot of students who don't know what to do for these types of questions. We know that when you want to find the place where two equations intersect, you make their equations equal to each other. So you make the third x minus 1 equal to the minus 2x squared plus 4x plus 6, and then you solve. By the way, we can see that they intersect at Q, so don't be surprised when you solve this and you get an x value of 3 as one of your answers, and then you'll get a different value for the P. Okay, so I'm going to take everything to the left, so we're going to have 2x squared plus a third x minus 4x minus 1 minus 6 equals to 0. And so 2x squared. Now this, if I type it on my calculator, you get negative 11 over 3x and then minus 7. I would not try factorize that in an exam. I would just go straight to the quadratic formula. So x equals minus b plus minus b squared minus 4ac over 2a. This would be my a, this would be my b, and this would be my c. So the teachers want to see you fill that in. So b is negative 11 over 3. And then once again, negative 11 over 3. A is 2. And c is minus 7. And then at the bottom, we have 2 times a, which is 2. Okay, go ahead. Type that all in on the calculator. Oh, actually works nicely. X equals to 3. Oh, lovely. We know we haven't made a mistake. Or x equals to negative 7 over 6. Okay, so we've got the x value of this point. Now to find the y value, you just plug that x value into either this equation or into this one. It doesn't matter. I'm going to go into that one. And so you're going to end up with a third multiplied and then minus 1. And that'll do, donkey. That'll do. If you know, you know. If you know what I just said, then we can be friends. Minus 25 over 18. Why are they giving us such shitey numbers? Minus 25. Like, if I get numbers like this in an exam, I'm stressing, bro. I'm like, what's going on? Okay, this question says calculate the maximum length of VW. Easy, marks. To work out the length of VW, you're just going to take the y value of the top graph minus the y value of the bottom graph. Let me explain why I say that. So let's say, for example, we have a parabola. and let's say we have a straight line going like that, and they want to know this vertical, they want to know the maximum length, or let's say that, no, they want to know this length over here, between here and here. And let's say we have the coordinates 1 and 8, and then this one is 1 and 3, because they would have the same x value if they are vertically above each other. So what would this length be? What would that length be? That length would simply be 5, because if this y value is 3 and this y value is 8, well then to go from 3 to 8, that's 5 units. So you see how I took the y value of the top one minus the y value of the bottom one, and that'll give you the vertical distance. So what you then do now is you say, okay, you go fill in the y value at the top, which is v. So you fill in the equation of that graph. So that graph's equation is this one over here, okay? Then you say minus, and then you fill in this graph's equation, which is this one over here. But because we're minusing, please remember to put it in a bracket. Okay, and now we can just go simplify a little bit. So minus 2x squared plus 4x plus 6 minus a third x plus 1. And then I just want to simplify a bit more, so minus 2x squared. I'm then going to put 4 minus a third on my calculator, and that'll be 11 over 3. And then the number of fractions I'm seeing in this question is giving me anxiety. Oh, if I was sitting in an exam and I was getting numbers like that, I would be like, yay, wat gaan nou aan? Now think about this. You've got this equation that says VW is equal to this, and they want you to find the maximum. So how do you normally find the maximum of an equation like that, which is a parabola? Well, you just go use the x equals to minus b over 2a, right? And so that would equal minus 11 over 3. Let's just try to squeeze this in here. Minus 11 over 3 divided by 2 times a, which is negative 2. And that would eventually give us 11 over 12. So now we know the x value, where the maximum is happening. So what you can now do at that x value is you can go plug it into this equation to then actually find the length of VW. So VW would then be minus 2 times 11 over 12 squared plus 11 over 3 times 11 over 12 plus 7. And this will give us, okay, so if we round that to 2 decimals, 8,68. 8,68. Because I ended up getting 625 over 72, but then I just changed it to a decimal. Okay, now moving on to this over here. Use the graphs to determine the values of x for which the graph of j, j is the parabola, increases. Okay, so where is j increasing? Well, we can see it's increasing over here, all the way up to the turning point. And then after the turning point, we can see that it begins to decrease. Okay, so it's increasing from the turning point all the way to the left. All of this is increasing. So you could say that x is smaller than the turning point value, which is x is smaller than 1. If you rather want to use interval notation, you could say x is an element going from negative infinity up to 1. We're not going to include the value of 1 because at that point the graph is not increasing anymore. Okay, now this question, they're saying that they want negative j of x over k of x to be smaller than or equal to 0. So this is one of those table questions where we're going to have to go see how to make a negative, how to make a positive, and all of that. The first thing is, though, this negative is really awkward. So what we're going to do is we're going to divide the other side with a negative. And if we remember with inequalities, when you divide by a negative, the sign changes. And so you can just end up with that. And so suddenly things look a little bit better. Okay, so we're going to have j of x over k of x. And we want that to be positive because that's what this means. Bigger than or equal to 0 means positive. It means 0 or positive. So when you divide two things, how do you get a positive? Well, that can only happen if you divide a positive number with another positive number, Or you divide a negative number with another negative number, because then the negatives cancel. So that is the only way that you can have a positive fraction when you're dividing two parts. So we either want j of x to be positive and k of x also to be positive, because then when you divide them, you're going to get a positive answer. Or the second scenario, you want j of x to be negative, but then k of x must also be negative, because when you divide two negatives, you still have a positive. Okay, so what we're going to go do now is we're going to go look at this first scenario, and we're going to try to see if there are any places on the graph where j and k are positive at the same time. So what I like to do is I'll start with the first one. So let's go find all places on the graph where j is positive. What does that even mean, j is positive? It means that it's above the x-axis. So where is the graph of j above the x-axis? Okay, there. So we've done that part. Now where is the graph of k above the x-axis? Well, that would be over there. Okay, so if you look vertically now, is there any place where the yellow part and the green part overlap? No, they don't. Because the yellow part stops over there and the green part starts over there. Okay? So there's not going to be any solution for that part. Some of you might be like, yeah, but Kevin, can't we say at Q itself? Because then the graphs are not, they're on the x-axis, so they would be equal to 0, and they said that 0 is allowed. Okay, I hear what you're saying. However, we can't, because at that point Q, yes, the graphs are 0, but so is the green one, and you're not allowed to have a 0 in the denominator. That's undefined. So we're not going to use Q at all. And there's no other place where those two overlap. So for this part here, where they're both positive, there's nothing. Okay, so we've done that. Now we're going to move on to scenario number 2, where graph J must be negative, so that means below the x-axis, so that's there, and that's there. And then graph K must also be negative, which is there. Okay, is there any overlap? Well, some learners struggle to understand what we mean by overlap, so let me help you guys with that. If we look at this green part, what are the x values? Well, can we agree that the x values start at Q for that green part, and they go all the way to the left? Right? Because if you think about what is the x value for that one, it's there. What is the x value for that one? It's there. What is the x value? So these x values match up with the green part, right? Those are the x values that correspond with this part over here. I'm just highlighting it on the x-axis itself. Now for the yellow part, that starts over here at R. Okay, now that's difficult color to see. Let me use, I'll use like a blue color. So R, you see this part over here, it goes from R onwards. So it goes there. Okay, and then this yellow part here would match up with that over there. So is there a place where the green and the blue are both overlapping? Well, yes. You can see that the overlap is all of this, starting there at R. You can see at R, we have both of them going together. So that is what we mean when we say overlap. They are sharing the same x values. Their graphs are sharing the same x values. Okay, so the answer then is going to be from R to the left. And then here there was no overlap. You can see there's only blue, but there's no, the green graph doesn't go over here. Okay, so they're not sharing x values. So the answer is all of this, right? That's what we said. So we said that we can say that x must be smaller than or equal to -1. We can include the -1 because it's the yellow graph, or the graph of J, that is touching the x-axis at that point. But J is the numerator in the fraction, and the numerator is allowed to be a 0. without causing any problems like undefined or whatever. Okay, and so we're just going to say x is smaller than minus 1. If you want to use interval notation, you can go from minus infinity up to minus 1, including minus 1. The memo got this answer totally different. They've done something weird, completely wrong. So yeah, that is the answer. Now we're going to move on to the last question. Okay, now this 8.6 says, for which values of k will the graph j of x minus k equals 0 have two distinct roots? So j of x minus k have two distinct roots. Okay, so roots are x-intercepts, right? And what you need to understand is that this part here is either going to move the graph up or down. So at the moment, if you look at the graph of j, how many x-intercepts does it have? 1, 2. And are they different or the same? They're different. Now, if k was a value of 1, what would that do to the graph? Well, it would move the graph 1 unit down. So this whole graph would then move 1 unit down, or more like there, and it would still cut the graph twice. What if k was minus 2? Well, then it would move the graph 2 units down, and it would still be fine. What if k was minus 5? Well, then it means it would move the graph 5 units down, and so you would still have 2 intercepts. But now, what if k was 7? Well, then this point here is an 8, so it's going to move all the way down to here where y is 1, and it's still going to cut twice. But if you make k equal to 8 now, then this is going to go on the x-axis, and then you're going to have a situation that looks more like that. And now we no longer have 2 x-intercepts, we only have 1. It's going to be like x equals to 1 and x equals to 1. So, and then if you had to go k as 9, well, then you're going to move the graph 9 units down, and now we've gone too far, and now you're going to have a situation like that, where you've now got no x-intercepts. So, and then what if k was a negative number? What if k was negative 1? Then that would end up becoming plus 1. So then you're moving the graph up by 1, and that's perfectly fine. You're just going to keep having x-intercepts. If you made it plus 10, then you'd move the graph 10 units up, and it would still be fine because these lines can just go on and on and on and on forever. So you see how the number 8 is kind of like our limit. So for example, minus 3 is great, but minus 9 is too far. So we don't want k to be bigger than 8. We want k to be a number that is smaller than 8. And that is the answer. So here are all the questions that we will be doing in this question, but I will be breaking number 9.1, 2, and 3 onto separate pages. So let's begin. Jeremy enters the quiz show Who Wants to Be a Millionaire? The objective is to answer consecutive questions correctly in order to win 1 million rand. A contestant's turn ends when a question is answered incorrect. Contestants may choose to answer the question themselves or use a lifeline. A lifeline may only be used once, and it must be used within the first 3 rounds of question. On the first attempt, the probability that Jeremy answers the question correctly on his own is 0.7. The probability that Jeremy answers the question incorrectly is 0.1. And the probability that Jeremy uses a lifeline is 0.2. If he does use a lifeline, the probability that the lifeline produces the correct answer is 0.9. Okay, so they want us to draw a tree diagram to represent the information for 2 rounds. Okay, so let's start with question 1. So the first question that Jeremy will be asked. He could either get that question correct, he could get it incorrect, or he could use a lifeline. Okay, now getting it correct, I'm just going to put a C. Getting it incorrect, and then using a lifeline, I'm going to put it L. Now for the lifeline part, he could either get it a correct one, so that's going to be 0.9. So that's going to be lifeline correct, and then he could get it incorrect. So lifeline incorrect. Now if we go fill in the probabilities here, we know that this one is 0.7. This one is 0.1. 1. So this would have to be 0.2 because these 3 must always add up to 1. Okay? Now, to get it correct, if you use a lifeline, is 0.9, and then this would obviously be 0.1 because these must always add up to 1. Whenever you have branches, they must always add up to 1. And then if you have other branches, those must add up to 1, those must add up to 1, those must add up to 1. So it must always add up to 1 at each little point. Okay, now let's just extend these lines. Okay, so can we agree that up until here, that represents one question? So that is one question. Or you can think of it as one round of question. Now they want us to go for 2 rounds, so we're going to go again now. So now, imagine Jeremy went this way. So what has Jeremy done if he's on that path? Did he get the question? Did he get the first question correct, incorrect, or did he use a lifeline? He got it correct. So does he still have a lifeline? Yes, he does. Because if he went this way, he hasn't used a lifeline yet. The lifeline is only if he goes that way. But we're just looking at this branch for now. So when we now go into the next question on this branch, what are the options that he has now for question 2? Well, he could get that one correct, he could get that one incorrect, or he could use a lifeline again. And if he uses a lifeline once again, he could either get that correct or incorrect. Okay, now let's just go for all the values. It's all going to be the same. He's always got a 0.7 chance of getting it correct. He's got a 0.1 chance of getting it incorrect. And then he's got a 0.2 chance that he chooses a lifeline. And if he then chooses the lifeline, if he gets it correct, he has a 0.9 chance. And if he chooses a lifeline and gets it incorrect, that's a 0.1 chance. Now, if we go down this pathway, then what does that mean for question 1? It means that Jeremy got it incorrect. So as soon as he gets it incorrect, it says here, a contestant's turn ends when a question is incorrect. So there will be no further branches. We could maybe add 1 and we could say, go home, Jeremy. Go home, Jeremy. Okay? So, yeah, that was a joke. But you get the idea. He can't do anything further after that. Sorry, let's just extend that like we did. And so there's nothing that you're going to add on over here. Okay, now let's go to this branch. If he used a lifeline and he got the question correct, is he allowed to stay in the game? Yes. So now he's allowed to enter round 2. But because he's already used a lifeline over here, we're only going to say that he could now maybe get the question correct or incorrect. He's not allowed to use a lifeline because a lifeline may only be used once and it must be used within the first 3 rounds. So he's already used his lifeline if we're using this branch. So the only options now is that he gets it correct with a 0.7 chance and incorrect with a 0.1 chance. Okay, so that is a little bit weird. That's the first time where those are not going to add up to 1 because he's not allowed to use a lifeline. So that's actually the first time I've ever seen a tree diagram that doesn't add up to 1 over there. So that's quite unique. Okay, now if he rather went down this other pathway where he used a lifeline, but he got the question incorrect, then is he allowed to carry on with the game? No, he's done. So this is what we are now dealing with. So all of the red is question 1, and then all of the green is question 2. Okay, I don't know why I wrote it as one question. Say question 1 and then question 2. Okay, now we can carry on. So determine the probability that Jeremy will, unassisted, answer the first 2 questions correctly. Unassisted means no lifeline, no using a friend's help. Okay, so where on this diagram are we going to see Jeremy getting 2 questions correct by himself? Well, that would be here and then there. So you see, that's the pathway that he would have to follow to get 2 questions correct by himself. So on a tree diagram, whenever you want to work out the probability of an entire branch like that, can you remember what we should do with these numbers? We should multiply them. So we're going to say 0.7 multiplied by 0.7, and that's going to give us 0.49. This last one says, determine the probability that Jeremy answers the first question correctly. Okay, so to answer the first question correctly would be that, and then using a lifeline, and then getting the first question correct. So those are the two branches we're going to have to look at. So this one is just 0.7. This one here is a whole branch. Can you see there? So it's exactly what we had over here earlier on. So what you're going to do is you're going to multiply the 0.2 and the 0.9, 0.2 multiplied by 0.9, and that's going to give you 0.18. So this entire piece is 0.18, and this entire piece is 0.7. Now, can you remember what we are supposed to do when you would like to add individual branches? Well, I just kind of said it. When you want to add the individual branches together, you're going to add the numbers. So you're going to say 0.7 plus 0.18, and that's going to be 0.88 over there. The events A, B, and C are such that A and B are independent. When A and B are independent, it means that the independent formula can be used. This formula is a formula that can be used when two events are independent. You might use it like this. Just remember that this means and. Now B and C are also independent, so we can use the same formula for them. I don't even know if we're going to have to use the formula. I'm just writing things down. And then A and C are mutually exclusive. When two things are mutually exclusive, it means that they cannot happen at the same time. So it means that the circles do not overlap. So it means that the part where it says A and C is actually going to be 0, because there is no part that is A and C. It doesn't look like this. If it looks like that, then there is a part that has A and C, and then it wouldn't be 0. But when it's mutually exclusive, then it's separate like that. So that would be probability of A and C is 0. Then it says that their individual probabilities will be that, that, and that. Okay, calculate the probability of the following. A and C. Well, that would be 0, because we just said over here that A and C must be 0. B and C occur. Well, it says B and C, and so there's B and C, and so you're just going to do this, and so it's going to be equal to probability of B and C is going to be the probability of B multiplied by the probability of C, and so the probability of B is 0.4, the probability of C is 0.2, and so if we then go and multiply this, we end up getting 0.08. Okay, so we've now done this question and this question. Now it says, what is the probability for 4 marks that at least one of A or B? So we know that in grade, we learned it in grade 11 already, that there is a formula that uses OR. You see how they've got OR over there? And so it goes like this. And it's a formula that is on your formula sheet, and then it has minus A and B. So we can then say that that's going to be equal to the probability of A, which is 0.3, plus the probability of B, which is 0.4, minus the probability of A and B, which we said over here is them two multiplied together. So we can just multiply them together like that. And so that's going to be 0.3 plus 0.4 minus 0.3 multiplied by 0.4. Go ahead, chuck that all in on the calculator, and it should eventually give us 0.58. A leadership camp organized for 103 grade 11 learners were asked to indicate their meal preferences. They could choose from chicken, fish, or vegetables. The following information was collected. Okay, now, not all of these values can be used immediately. So let's see here. 2 learners do not eat chicken, fish, or vegetables. Okay, so they just on a water diet apparently. Or there the 2 learners are, they don't eat any of that food. And then 5 learners eat only vegetables. There they are, only vegetables. 8 learners eat only chicken. Okay, why are they showing us the values already on the diagram? This is awkward. 23 learners do not eat fish. Okay, that's interesting. You can't put that anywhere on the diagram. 23 learners do not eat fish. So that's where the 23 learners are over there. You can see that they are not inside the fish circle. Okay, so 8 plus 10 is 18, plus 5 is 23. And then 3 learners eat only fish. There they are over there. Okay, so let the number of learners who eat chicken or fish be x. Okay, chicken or fish. That's not actually chicken or fish, by the way. That is chicken and fish. Caught you out, whoever set that exam. Okay, so calculate the value for x. Okay, very easy. We know that all of these numbers added together should give us 103. How much easier would you like the question to be? So you can just go 8 plus 10 plus 5 plus 65 plus 5 plus x plus 3 plus 2, and all of that should add up to 100. And so what we will eventually get, what I would do is I'll just go add up all these numbers on my calculator, and that'll give us 98. And then we still have the plus x. I would take the 98 over, and you're going to get 5. So that's the value of x, it's 5. I would then fill that in. Okay, now this question over here says, calculate the probability that a learner chosen at random eats any 2 of the given food choices. I don't like the question because it's a bit confusing as to what do they mean by, do they mean 2 only or at least? So I went and looked at the memo, and this word should have been at least. So then it means that three foods are also allowed. Okay, so if that confused you, I don't blame you at all. Because some people might read that question and think, okay, do they only mean 2, or do they also mean that you can have 3? Like, are they also, like, do they only want us to look at the people who eat 2 foods only, like chicken and veg, fish and veg, and then chicken and fish? Do we only look at those people, or are we also allowed to look at the people who have 3 foods, which is chicken, fish, and veg? And so they got the wording a bit wrong. It should say at least. So when they say at least 2, it means that 3 is also allowed. So it's going to be all of these people over here. Okay, so you're going to say 5 plus 5 plus 10 plus 65, and we're going to divide all of that by the total, which is 103, and you end up with 85 over 103. The length of 80 worms in centimeters is recorded in the table below. Okay, why are they catching worms? This is weird. It's like some hillbilly town. Maybe it's like Alabama. Can you just imagine like the 2 teenagers who are busy catching these worms, and then they get interviewed on like live television, and they're like, hi, so would you please tell us your names? They're like, oh hell yeah, my name's Randy, and this is my sister Petunia, but I'll tell you something special about Petunia. She also happens to be my girlfriend. We be dating for about 2 years now, and she's the love of my life. I'm gonna make this woman my wife. Okay then. Sometimes when we catch the worms, we even eat them for dinner. Hell, get some good protein over there. Okay, I need to snap into maths mode. Sorry, guys. So, the length of 80 worms in centimeters is recorded in the table below. And then suddenly the dad comes onto camera. His name's Bo, and he's like, Randy, what'd I tell you about kissing your sister on live television? If you want to be doing that, you go do that in closed doors. Thank you, son. Okay, guys, I think I need help. Who comes up with these jokes? Okay, I promise I'm being serious now. The length of 80 worms is recorded. Okay, so I'm just picturing you guys who are watching this right now. I'm so sorry, guys. I'm sorry. I think I was dropped when I was a kid. But okay, so what they did is they went outside one day and they went and catched worms. In the category from 0 to 5 centimeters, they were able to catch 9 worms that were in that length category. Then they were able to catch 21 worms that were somewhere between 5 and 10 centimeters, and you get the idea, right? So if you had to add all these numbers together, you would notice that we caught a total of 80 worms. Now it says, now this is actually a very interesting question. You've got to read it carefully. It's not as easy as it seems. Determine the probability that only one of the worms is 5 centimeters or shorter. Okay, so that means in this category over here. And the other worm is longer than 15 centimeters. So that would be these 2 over here. Now, you can't just go and add, you can't just go and say, this plus this plus this, because that doesn't tell us that they actually chose a worm that was shorter than 5 centimeters. Because if you just went and added those numbers together, you would have said 9 plus 17 plus 8 over 80. But what that is just doing is it's saying, what is the probability that you choose a worm that is somewhere in this category? But it doesn't tell us that we're choosing 2 worms, and it also doesn't tell us that we are definitely choosing one from there and one from there. If you just do it like this, it means we're only choosing one worm, and both of them, we're only choosing one worm. It might even just come from here. It might not necessarily come from there. So how are we actually going to do this? How are we going to make sure that one of the worms is definitely smaller than 5 centimeters and the other worm is longer than 15 centimeters? And they don't really make the question very clear. Like, where do the 2 worms come from? So what you got to imagine is that when Randy and his sister Petunia, or his girlfriend and his sister, they're the same thing, when they walk into the house, the dad, Bo, he's like, okay, I'm not going to put accents on anymore, guys. It's getting old now. But Bo, he wants to choose 2 worms from that bucket of worms, and he wants to make sure that one of the worms is going to be 5 centimeters or shorter, and the other is longer than 15 centimeters. Okay, so the only way that this can work is that, okay, there's 2 scenarios, or there's 2 ways it can go. The first one is that for the first worm that he chooses a worm that is shorter than 5 centimeters, plus he then chooses a worm that is longer than 15 centimeters. Okay? The other scenario is that he first chooses a worm that is longer than 15 centimeters, and then the next worm is going to be shorter than 5 centimeters. Okay, but we're actually not going to be plussing them. We're going to end up multiplying them, because whenever, it's almost like being on a tree diagram. Whenever you do one thing and then you do something after that, you multiply them. So what is the probability that it's going to be shorter than 5 centimeters? Well, that's going to be 9 out of 80. Now, if he's already chosen a worm, then for the next one, it's going to be 79. They didn't tell us here, but you got to almost imagine that he chooses a worm and then he doesn't put the worm back into the bucket. Okay, the question's very vague. Like, what the heck, man? Come on, do better, examiners. Now, for the next one, what is the probability that it's going to be longer than 15 centimeters? Well, that would be 17 plus 8, which is 25. So we could work that out, and you would get, okay, so you get 45 over 1264. But then the other scenario is that he chooses the longer worm first. So that's going to be 25, but now there's going to be 80 worms, because imagine in this scenario, he's choosing the longer worm first. So there's still going to be 80 worms. And then he chooses the shorter worm second. So now it's going to be 9, but there's only going to be 79 worms because he's already chosen a worm over here. And so if you work this out, it's also going to give us the exact same answer. And so when you have 2 different options like this, what you now do is you add these 2 values together, and that would eventually give us 45 over 632. In decimal form, it's approximately 0.071. In percentage form, it's like 7.1%. Okay, not really a good question, very open-ended. I wouldn't stress too much if this one was weird.